welcome to the video for section 2.1, and this is the beginning of actual trigonometry. We are now outside of our algebra review, and so here we go. Number 1 asks us to convert the degree, minute, and second measure into a degree in decimals rounded to 2 decimal places. And so what we do is we take the number of degrees plus the number of minutes times 1/60th plus the number of seconds times 1/3600th. And when we do that, just punching that into the calculator, on this first one, we get 32.71 degrees. Doing the same thing for number 2, we have 21 degrees, 17 minutes, and 34 seconds. 21 plus 17 times 1/60th plus 34 times 1/3600th. And punching that into the calculator, is 21.29 degrees. Next group of problem, if S denotes the length of the arc of a circle and radius r subtended by a central angle theta, find the missing quantity. And this is going to use the formula S equals r theta. R in this case is 13.38 centimeters and theta is 3.5 radians. So all we have to do is plug those values in, 13.38 and 3.5, and realize theta here does need to be in radians. But when we take 13.38 times 3.5, we get 46.83. Since we are talking a distance here, this is the length of the arc. It would be 46.83 centimeters. Number 4 has a picture where the central angle is pi over 3 and the radius is 7 meters, and we need to find S, the arc length. So it's just a matter of plugging in the values. The radius is 7 meters. The central angle is pi over 3, and so this becomes 7 pi over 3. Putting the appropriate label would be meters. Next group of problems are word problems, and so we do need to read those. For a circle of radius 4 feet, and pictures are always good. So we have a radius of 4 feet. Find the arc length S subtended by a central angle of 30 degrees. So we need 30 degrees as the central angle, and we're looking for S. Now, in order to use S equals r theta, we do need to have theta in terms of radians. So a very quick calculation, 30 pi, or 30 degrees, and for every pi there is 180 degrees. And so this does simplify to become pi over 6. Also, it's very important to realize 30 degrees should be an automatic pi over 6 conversion, because it's a very, very common degree or angle. And so S would equal the radius of 4 times the central angle of pi over 6, which equals 2 pi over 3, and the appropriate label would be 2 pi over 3 feet. Number 6. The minute hand on a clock is 4 inches long. How far does the tip of the minute hand move in 45 minutes? Well, in 45 minutes, it's going to move all the way through that much of an angle. Now, as it turns out, in radians, that is 3 pi over 2. 3 pi over 2 is the radian measure of this angle right here. Now, if we multiply that by the 4 inches that the radius is, we get 6 pi. Putting the appropriate label, we get inches. And so the final answer would be 6 pi inches. 7 and 8 ask us to convert the angle in degrees to radians and express the answer as a multiple of pi, which basically means we're going to have some sort of a fraction, potentially, and a pi within the answer. We get 36 degrees. All we need to do is multiply or realize that for every pi, there are 180 degrees. And then it's just a matter of simplifying this fraction. 36 over 180 would actually, we can take out 18 out of both of those and get 2/10, which can simplify further to pi over 5. And that would be the answer for number 7. For 87 degrees, we do the same thing. Take 87 degrees, multiply by the pi over 180 degrees, and then simplifying this, it doesn't appear that 87 or 180 will simplify with each other, and so we get the answer 87 pi over 180, and that would be the answer for number 8. Number 9 and 10 asks us to do this same thing in reverse. We're going to change radian measures into degree measures. So number 9 is 4 pi over 3. Now here we need to realize there are 180 degrees for every pi. And so simplifying this, realize that quite often the pi will disappear, or the pi will not disappear. They will cancel each other out, and so we will be left with a number such as 240 degrees when the multiplication is done. Number 10, 5 pi over 2 times the 180 degrees for every pi. Once again, the pi's will simplify each other out, and we get 450 degrees when we do all of the necessary multiplications. The next two problems deal with area of a sector, and we will be given some information. We'll be given two of the three: central angle, the radius, or the area, and we need to find the missing value. So number 11, we know the radius and theta. So the area, we're going to use the formula area equals 1/2 of r squared theta. And so just plugging the values in that we know and what we need to solve for. So, the radius is 6 inches, and the angle is 3 radians. Once again, the angle does need to be in radians. So this is 1/2 times 36 times 3, which when you multiply all of that out becomes 54. Putting the appropriate label, 54 square inches. Number 12, we know the radius and we know the area. The area is 34 and the radius is 4 feet. We need to find theta. And so 34 would equal 1/2 times 16 theta, or 34 would equal 8 theta. Dividing both sides by 8, theta would become 17/4. Problem number 13 is just a diagram of the problems like number 11 and 12. We need to find the area. And we know that that is 1/2 times the radius. According to the diagram, that is 5 feet. I have to square that, times theta. Theta in this case is pi over 4, which will equal 1/2 times the 25 times pi over 4. And simplifying here, because actually nothing will simplify here, it's just a matter of multiplying, we get 25 pi over 8. The appropriate label would be square feet, because the radius was given to us in feet. The final group of problems here deal with word problems, and so we will continue, or we will do the first problem here on this video. A circle has a radius of 6 centimeters. Find the area of the sector of the circle formed by the angle of 75 degrees. And if necessary, round the answer to 2 decimal places. This is highly possible because 75 degrees at this moment is not a very easy conversion into, well, no, it is actually fairly easy conversion, so let's see what the area would be. Area would equal 1/2 times the radius squared, or 6 squared, times. Okay, 75 degrees. We need to do a quick conversion. We're going to do that by taking pi over 180 degrees. And this will simplify to, what? Let's see, 5 will go into both of those. So 25 pi over 15 pi over 36, and 3 will go into those still the same, so 5 pi over 12. Continuing this on out, 1/2 times 36 times 5 pi over 12, and then doing the multiplication, we would get what? 3/2 would be 15 pi over 2. Putting the appropriate label, we would get square centimeters. We will continue the on the next video.